Using clear mathematical language, explain how you determined your formula for the sinusoid that models the daylight data. Well, to start, I looked at the most basic equation for a sinusoid. Y equals A sine or cosine b x minus h plus k. So you can see here the values that we needed to find were A, the amplitude, b, which equals 2 pi over the period, h, the horizontal shift, and k, the midline. I started by solving for k, the midline. You can see here the data we were given based on Boston's hours of daylight. And two data points that stuck out immediately were the maximum on June 21st and the minimum on December 21st. And after finishing the packet, it's clear that these dates are equinoxes, the summer solstice on June 21st and the winter solstice on December 21st. But back to get solving for the midline. This equals the average amount of daylight in Boston. So you can solve that by adding the maximum and the minimum and dividing by 2 to find the average. So I plugged that in here, and that got me the value of 12.17 hours. So now we have our midline. We can move on to the amplitude. The amplitude, or the A value, equals the difference between the average, the midline, what we just solved for, and one of the maximums or the minimums. So I plugged in the maximum of 15.27, subtracted 12.17, the value we just found, and I got 3.1. Now, to decide whether it's going to be a cosine or a sine graph, and whether your amplitude is positive or negative, you need to look at where the graph is starting. Because we're beginning at December 31st, we're starting at a low point on the graph and we're increasing. Therefore, we know that it's a cosine graph because it starts towards closer to the minimum, as opposed to the axes where a sine graph would start. And whether it's a negative or positive cosine, well, you can see here I've graphed cos x, and you can see that the positive cosine starts at a maximum and decreases. So this graph, starting towards a minimum and increasing, is the opposite, so it's a negative A value. So the A value, or the amplitude, is negative 3.1. And here, to solve for the H value, or the horizontal shift, you can the problem asked for us to start at December 31st, and we were only given the data for December 21st. So you can see here the difference between those two dates is 10 days, and that equals a rightward shift of 10 days. So the H value is equal to negative 10. And finally, the period, or the B value, and you need to find the period to solve for the B value. The B value equals 2 pi over the period, and we know that one full period equals a year, so 365 days, and you can see that I solved that out, so the B value equals 2 pi over 365. And we know that this is one period because after 1 year, that is when the Y values start to repeat. And so then by plugging all that in, you can see that H of t equals negative 3.1, cosine 2 pi over 365, t plus 10 plus 12.17. So that is the final equation, and I graphed that on GeoGebra, and you can see this is the final result. The graph, I marked the two equinoxes on the midline, and I have the coordinates for those points up here. And,
This is a really cool real-world application of the skills we're learning in pre-calculus.